Thank you for joining Modern's webinar on Civil 3D Subassembly Composer. My name is Salome Puri and I am the Infrastructure Accounts Manager. Presenting today will be Andre Iman. Andre is one of our applications engineers and part of the Modern infrastructure team. Please direct all your questions to the Q&A box, or the questions will be answered at the end of the presentation. The webinar will be recorded and will be emailed through shortly after the webinar. If you have missed any of our previous webinars, you are welcome to come and visit our Modern YouTube channel. For any other queries, you are welcome to email me or contact me. My details will be in the chat box. Andre, over to you.
Thanks, Salome. All right. So welcome, everyone. Today we're going to be going over the Civil 3D Subassembly Composer. So firstly, why do we use the Subassembly Composer? Well, first of all, it is to create custom subassemblies. So essentially, so that we can supplement our software, our Civil 3D, with additional functionality and additional subassemblies, especially if we have custom cross sections that we do need to conform to. It provides an easy to understand interface that allows you to easily compose and modify complex subassemblies. And you don't even need to be an expert programmer for this. With very little practice, you can get quite nice subassemblies going. You can build almost any subassemblies from any form, link, or shape that you desire. It can also be used again and again and changed and re-imported into Civil 3D if need be. So just before we start, a footnote on the installation of the software. Once you install your Civil 3D software, do note this is a little bit of an older screenshot, but it is the same in the newer versions. You do get prompted to actually choose to install the Civil 3D Subassembly Composer as you install Civil 3D. Now, for newer installs, say for example, you installed your Civil 3D, but you didn't install Subassembly Composer, you do get the option to install the setup.exe file after the fact. Okay, just going over some quick terminology that we're going to be using during this webinar. Firstly is points. These are cross-sectional points that essentially determine geometric objects such as the crown of your road, the edge of your traveled way of your road, so the edge of tar, things like that, the flow line of your curb and channels and those kinds of things. Links essentially indicate the cross-sectional surfaces such as the top surface of a road or the bottom earthworks surface of a road. The shapes indicate the cross-sectional area of any subassembly. That would be, for example, the cross-sectional area of concrete through a curb or a channel, or the area of asphalt in your road surface. Targets then refer to, let's say, for example, you need to point a cut and fill to a surface at a certain slope. That is what a target refers to. It is that surface that you're pointing to, or a profile that you are following for additional information on your subassembly. SAC is just an abbreviation for Subassembly Composer, and PKT is the file type that Subassembly Composer uses to save your subassemblies to. That is a packet file which can then be imported into Civil 3D itself. Okay, so let's just go over the quick general subassembly development process before we actually dive into the software and go and do an exercise ourselves. So the first step that I usually follow is I just take a piece of paper and a pen or pencil, and I just roughly sketch out the cross section of the subassembly that we're going to be creating. So as you can see here, here's a rough sketch that we did. So we have a little bit of a curb and channel. So we have some concrete. Let's say, for example, it's going to attach to the edge of your road over here, right over there. We have the first width, which is just a flat piece of concrete there. We then have the channel itself with a channel depth to the flow line. We have a second width, which should be around the same as the width on the left-hand side. We have an overall concrete depth, and then we have an overall concrete width. Then what I usually do is I just take this over into Civil 3D quickly, and I just draw out just into a cross section of my subassembly. This is where I can then just add some dimensions, just make it a little bit easier to understand, and it's a little bit more readable than the rough hand sketch. I would then go through and create a small just a flow chart in PowerPoint or something like that. Do note that this one was created in Visio. I do not believe that this software exists anymore. As you can see here, I go and I say, okay, let's use the start node. This you will see reflects nicely to the actual interface of Subassembly Composer. So I'm going to start. I'm going to then identify the origin or the insertion point of my subassembly. I'm then going to go and set up my targets and my basic parameters. And then I can go and actually create a point. Then just rinse and repeat this, this specific step. Okay, then we go over to actually building the subassembly in Subassembly Composer. So that's what we're going to be doing after we go through these steps. We're going to physically just go through a subassembly, just the interface, and then we're going to build one on our own. Okay. We will then import this subassembly into Civil 3D. I will show you guys this process as well. Then the main idea is that, you know, it might be a rough subassembly that you compose firstly, and then you would need to actually go and test the subassembly. You would test it, and then essentially what we want to do is we want to break the subassembly a bit. We want to push it to its limits. Okay. Then you would refine the subassembly. So if you've got any additional parameters or targets that you need to set up, any additional links or points that need to be defined, you can then refine the subassembly by going and adding those in. Once you then get to a point where you're actually happy with the subassembly that you have created, you can then document this process. Okay, so you can just write up a small document. It is preferred to do that so that you can, if you ever need to go back to the subassembly in future, you can always come back to it and change it, and you would know exactly the steps that you have followed. All right, so let's jump into composing a subassembly. So I'm going to quickly switch over to my subassembly composer just to go through a basic subassembly that I've already created. It is a lot similar to the one that I just showed in the presentation itself. So the first thing that I would need to do is I would need to go and physically open up this subassembly first. So I've already created this one. It is called Concrete Valley Gutter version 1, just so that I can keep track of my versions on this subassembly. And you will see that it is a PKT file. So I'm just going to open up this PKT. Okay. I think we can just continue on the screen. Sorry for the interruption there, guys. So I've opened up the subassembly here. Okay, so we can just continue on with this screen over here. So what I have is I've opened up the subassembly. I can now go and just see what I have done in this previous one. So let's just quickly go over the interface over here. So the first thing that we can actually see is the following. So we have a flowchart area. Okay, so this is where you can actually see the start point of your subassembly as when you create it, then your flowchart as you go through and place your points and set up your parameters. I will go through these shortly. On the right-hand side here, you see a preview. This is where you can actually see a visual view of the subassembly which you're creating or which you have already created. This is where you can actually switch between layout mode and roadway mode. So I'm currently, I believe, in roadway mode. Now I'm in layout mode, and this is where I can see my subassembly with all of the default values specified in the subassembly itself. Okay, so I've set up some parameters with default values, and this is how it displays. If I switch to the other mode, this is what it will look like when I initially bring it in to Civil 3D. So the idea with this subassembly is that it is a valley gutter or a curb channel. This point over here would insert on the road edge. This is the insertion point of the subassembly. I then have an overall width specified to the subassembly. I then have a valley or a flow line point down here. And the way that I've actually set this one up is so that it can follow a separate vertical alignment or profile. I will go through the process of setting this up. Then at the bottom here, you have firstly your packet settings. So I just switched over to my packet settings. This is actually where you go and set up the name of your subassembly. Do note, this name cannot contain any spaces. Then you can set up a description if you want to, and you can also take control of your major and minor versions on this subassembly. You can also link it to a page and a help file if you create a page for this subassembly. You can also attach an image to the subassembly. Then you have your input and output parameters. This is just where we set up the basic parameters that when we import the subassembly into Civil 3D, when we select the subassembly and look at our properties palette, it will actually show us these properties that we can then specify custom widths and depths to. Okay. These variables are then assigned to our individual subassembly objects, such as points and links. We then have our target parameters. This is where we actually set up our targets. Super elevation and cant detail is then automatically populated the moment that you create a subassembly. So we don't need to really worry about these two for something like this. These ones are more applicable to your roads and railways. Then in your event viewer, this is where you will see any messages relayed if there is an error that pops up on one of your subassembly objects. Okay. At the bottom here, we have properties. Say, for example, I select one of my options, such as my first point or P1. I can actually then set up the properties such as the delta X, delta Y, so that's your change in X, change in Y from a specific point. We can apply point number and point codes to these objects, as well as the geometry type. Geometry types vary from an angle to delta X. So this is essentially the behavior of this point from the origin point. If you want to then create a link as well, you can create a link from the previous point to the point in question, such as the one I have over here. You will see that it is linked to a different point. And then finally, on the interface, we have the toolbox. This is where you will find your specific geometry objects. So you can simply select an object, drag it and drop it into the flowchart area, and it will link to the previous function that you have inserted. Just to go over some of the geometry types that we have here, we have basic geometry or just geometry. This is where we can find our points, links, and shapes, which are the three main aspects of any subassembly. We then have some advanced geometry, such as intersection points, surface links, fillet arcs, and loop geometry. There are also some auxiliary geometry functions here. These are, for example, going to be used like this dashed line over here. I will explain this process when we start up a new subassembly. Then you can also create separate flowcharts, sequences, decisions, and switches. This is a little bit more in the programming direction of the software. There are also some miscellaneous functions as well. Okay, so let's quickly go through creating this subassembly. So I'm going to close the subassembly, or I'm just going to start a new one. I'm not going to save the changes I just made here. So essentially, this is now the starting point of our subassembly. We have our start point, we have empty layout mode, we have absolutely no packet settings or input-output parameters. Everything is completely blank. So the first thing that I usually go and do before I do anything else is I apply a name. Let's quickly go ahead and do that. I'm going to call this, let me choose a different name. Let me say curb gutter. I'm just going to give it that name. Remember to not have any spaces in there. Then for my input output parameters, now I'm referring back to the presentation where I actually went through and showed you guys, let me just quickly go there, those widths. So I'm looking at setting up width 1, width 2, the depth of my flow line, the concrete width, and the depth of the concrete itself. So let's go and quickly do that. I'm going to head on over to input output parameters, and I'm going to create a parameter. I'm going to double click in the name column, and I'm going to start by, let's say, concrete width. Do note you cannot have spaces in these names either, but you can have spaces in the display name. That is the name that will actually display in your properties palette in Civil 3D. I will then go and say the default value is going to be 1.5 meters, and the display name is going to be concrete width. You can add a description if you want to. I'm then going to go ahead and create the second one, which is the concrete depth. I'm going to say the concrete depth is, let's say 0.25. Might be even smaller, but this is just a default value that is now specified. Let's then go ahead and change the display name to concrete depth. Then I need to go and specify those widths. So I have width 1 and width 2, and then valley depth. Width 1 is going to be, let's make it 0.15 meters, so 150 millimeters. I'm just going to call this width 1. Then width 2. Oh, no spaces. Let's make this the same as width 1, 0.15. The spacing will be width 2. Then the final parameter that I create is my flow line depth. Let's make this 50 millimeters, so 0.05 meters. All right, and there we have our basic parameters now set up. Now, what we need to do next is quickly go and create some target parameters. Now, let's say, for example, what I want to have is that from the origin to the other end of my curb gutter, it should essentially be, we should essentially be able to control that with an offset alignment. So what I'm going to do is I'm going to go and create an offset parameter. I'm also going to create an elevation parameter so that we can control the depth of our flow line with a different vertical alignment or profile. So those are the two parameters that I'm going to create now. I'm going to head on over to target parameters. I'm going to create a parameter. Let's call this off or target offset. The type is going to be an offset target. And let's say the preview value is not 0. It's 1.2. So I'm intentionally making this a little bit less than the original or the overall default concrete width, just so that I can show the difference between the roadway mode and layout mode. The display name is going to be offset target. I will then create another parameter, and let's call this target elevation. This parameter is going to be an elevation type. Let's make this as well 0.05. I'm now just matching that to the original or the flow line depth. I'm going to call this parameter, give it a display name, elevation, or let's say flow line depth, flow line elevation, rather. It has to have a different name and display name than the general input-output parameters. And that's it. Our basic parameters have now been set up. We can now start creating our subassembly. You will see here that it actually does display the target offset and the target elevation. It might look like it's pointing directly to the center, but that's just because we aren't zoomed in yet. We'll see once we start populating how these update. Okay, so the first thing I want to do is I want to start with the origin point. The origin point is going to be on the origin itself. So I'm going to go and grab a point. I'm going to drag it into the start menu or into the flowchart here. You will see that if you do have a little bit of OCD, you can actually move it around to make the line straight. Okay, so you can actually move those around. So the actual placement of these objects inside of the flowchart does not have any bearing to the outcome of your subassembly. All right, so I'm just going to leave this on P1. I'm going to mostly go with just the default names on these objects. You will see in the properties here at the bottom that we have a point code or point number. Firstly, that's just a number. I can then add codes. Do note that codes need to be in these signs. So I'm going to say the first code is P1. Let me just switch on P1. And I'm going to say another one. So I'm going to put a comma there and hinge. These point codes are available in the code set style of Civil 3D. It does have to correlate to that code set style present inside of your Civil 3D template. Okay, the geometry type is going to be delta X and Y. The point that it's going to be based on is the origin itself. So it's going to be based on the origin point, and it has to stay on the origin. So I'm going to leave delta X and Y as 0. The next thing I want to do is I want to add an auxiliary point that is going to control the width of my, that's going to actually control the width of my object. So I'm going to go say auxiliary point, and I'm going to drag that into my flowchart. You will see that is AP1 and AL1. The reason why it's named like that is because it creates a point. Let me just quickly fit to screen. Okay, not yet. So it's because it creates an auxiliary point a certain distance away from point 1, as well as a link from that point. So you can see that it automatically creates a link by default. If you don't want to create a link, you can just switch that off. Okay, so let's say this is AP1, it's based on point 1, but I wanted to take the width from one of my parameters. So I'm going to say my delta X is going to be concrete width. What you will now see is that if you hit fit to screen, it will actually apply that default width of, there we have it, 1.5 meters to this object. That is now our auxiliary point. It does not have to change in elevation. Okay, so I'm happy with this. Now what I want to do is I want to go and start sketching out with actual links and points the basic shape of this subassembly. So I'm going to go and take a point and drag it into my flowchart. This is now point 2. I want it to be based off of point 1, and I want to go downwards. I now want the bottom link here. So I'm going to say base this on point 1. Let's maybe just add a code. I'm just going to add the code P2, just using the standard point codes. Okay. Now, because I want this point to go straight downwards, I'm going to say the delta X is 0, but the delta Y has to pull from concrete depth. So I'm going to supplement that with concrete. It has to be a negative value, negative concrete depth. There we go. You will see that it has moved that point downwards. And because I specify a negative variable, it will take negative 0.25 or minus 0.25. But I also want to create a link going down to this. So I'm going to scroll down to my properties and click add link, and it will add that link in for us. Now I'm just going to go ahead until I reach AP1 again. Okay. So I'm going to go and select another point and drag it into my flowchart. And let's say this is P3 and L2. I'm going to call this point P3. Note that you do not need to give vertical links any codes. It's not necessary. Okay. Now this point is based on P2. I want it to go directly towards the right. So I'm going to specify a delta X of, let's say, it has to match the link length of auxiliary link 1. So I want it to be so that if my link 1 length changes, it has to essentially adjust my P3 as well. So let's call this AL1 dot length. Okay, just give me a second. Let me just quickly go over to the other subassembly there. Just want to save this one. Double check something from the other subassembly quickly. Let's call this Curb Valley Gutter version 2. It is AL1 dot length. Okay. I'll just need to go double check the naming convention in mind then. All right. Let me go open up the other one again. Okay, so let's double check that. There we go. It took now. It just didn't take earlier. I just needed to go double check that. All right. There's one thing that I do want to go fix, however, because what I'm seeing now is that on my auxiliary link 1, I wanted to actually be able to take my target offset as well. I went and specified concrete width on here, which takes only the variable specified in your properties then. I wanted to be able to be overridden if I do have an offset alignment. So what I'm going to do is I'm going to, for the auxiliary point 1 and auxiliary link 1, change the type to, let's say, slope and a delta X. Essentially, what this allows me to do then is say I wanted to slope at 0% away from point 1. It will go flat. And I want the delta X to be, let's say, concrete width. There we go. It has now conformed. But what you will see now is that with the new type that I've selected, I can actually set an override for my offset target. I can make it so that if an offset target is found, it will override the value specified in the properties. Now, if we have an offset alignment specified in Civil 3D and we have a widening or something happening on there, it will actually stretch auxiliary link 1 and thereby stretch point 3 along with it. Okay, so let's continue. I'm going to drag another point in, and what I essentially want to do is this is going to go upwards from point 3. Let's say this is point 4. I'm going to add the code point 4 or P4. The delta X should now be 0. The delta Y will become, let's say, concrete depth, because that value is already a positive. There we go. It's back up to auxiliary point 1. Now this whole link, this vertical link, will move as our offset target dictates or as our properties dictates. Okay. For link 3, we don't need to put a link code. However, one thing that I forgot to mention is that we do need to specify a link code on link 2. Because it is at the bottom, we wanted to be able to form a datum surface, which will help us calculate earthworks quantities. So I'm going to add the code datum to that link. There we go. Datum has now been added to that link. Now what I want to go and do is I want to add a function, show you guys a nice trick of how we can determine the valley point of our gutter. So the first thing that I need to go and do is I want to go and add a point in on this link here. So I'm going to just add an auxiliary point. Let's deactivate the link because we don't actually need much of a link there. And what I want to say here is that this point, it doesn't need a code because it's auxiliary, but this point needs a delta X of, let's say, it has to be exactly halfway the length of the auxiliary length 1 so that it can always stay in the middle of it. So what I need to specify is that because it's going from the auxiliary point 2, let's say auxiliary point 2, or that's auxiliary point 1, the delta x has to be negative, let's say AL1 dot length divided by 2. So you can actually just add functions straight in like this. Okay, it's not taking that one. It seems that it's having a little bit of a hard time updating this one. Okay, let's just go with concrete width. So essentially what it does is it's supposed to put it halfway in the middle there. Just go and double check. And this is why these things take a lot of refining work. So we have L2 that is AL1 dot length. Let's go back there. Let's say, okay, AL1 dot length divided by 2. There we go. It just didn't take earlier. So it seems that I do need to enter these once or twice before it actually takes for some odd reason. Okay, so it is exactly in the middle of our auxiliary link now. Now what I want to do is I want to go and find a point directly down from here that will be controlled by our elevation target. Okay, that will be our valley point. So let's go and add a auxiliary point. So this will be auxiliary point 3. For this one, you don't actually need a link either. However, it doesn't really matter for this one. I'm going to choose a type of slope and delta x. The slope here doesn't really matter. It does not affect the object whatsoever. Delta x can be, let's say, flow line depth or negative flow line depth, because that is a positive variable. And then the elevation target override has to be target elevation. Okay. Delta x has to be removed. So that has to be 0. Negative target elevation. Okay. Being a little bit stubborn here, let's maybe say the preview value is negative. There we go. So all I had to do was change the preview value so that it actually goes downwards. Now I can quickly go and add in my 2 vertical links, which will be determined by width 1 and width 2. So I'm going to add in a point. This one does require a link. The method is delta x and delta y. The from point is point 4, which is the one here in the corner. The delta y will be 0. The delta x will be, let's say, negative width 1. There we go. Let's just create a link for that. And let's give it a code of top. This is so that it can form part of the top surface of your road when performing stormwater calculations. Okay, now I'm going to add in the link from the other side. This one's going to go from P1. So let's add in another point. From P1 Let's give this one a point code P6. And I can give this other one a point code of P5. Okay, let's specify a delta X here of width 1. The other one should probably be width 2. Doesn't really matter. You can have them either way around. It just depends on your preference there. I'll just switch them around. Okay, so we have our 2 flat links. Now all we need to do is we need to go and create a point on AP3, on auxiliary point 3, and then connect some links from point 6 and point 5. So let's go and do that. Let's add another point. Let's say this one is going to be on auxiliary point 3, and it doesn't change in delta X or delta Y. So it stays on point 3. So however the width of this object is affected, point 7 will move along with it in the center of the structure. Okay, let's just add the point code P7. And now I can just go and add 2 links, one from point 6 to point 7 and one from point 5 to point 7. Let's add a link. So I'm being a little bit pedantic on these things. There we go. The link code here is going to be top. The start point is point 6. The end point is point 7. And there we go. It creates that link between there and there. I'm going to add the final link here, which is link 7. It's also going to have the top point code. It's going to go from point 5 to point 7. And there's our basic structure done. The last thing that we need to add is a shape so that we can obtain quantities from this structure. So let's take a shape, drag it and drop it, give it a code, let's say concrete. And then we need to specify the links. Now, when you click on specify links, you can just hover inside of the object and click. That will automatically then create your structure. Now you have a full object here set up. Might be just one thing that I do need to check. Okay, that's P5 top, P6 top. There we go. So that is the whole structure. Now, if you have a width offset or you override it by typing in a different width for the structure in Civil 3D, it will actually adjust this whole structure accordingly. The only difference here is that you do need to apply a profile or vertical alignment to control the depth of your channel. Okay. So what we need to do now is physically go and save the structure again. I've already given it a name, so I'm just saving it. Now, final step. Let's say you want to go over to Civil 3D and you want to import this object. All you need to do is close your subassembly composer. Let me just navigate over to my Civil 3D. There we go. What we need to do here is we need to firstly open up on the Home tab our tool palettes. Just drag it somewhere where you can see it. There we go. So this is the tool palette containing the list of our subassemblies. You can right click on any of these tabs, choose new palette. I usually create a new palette containing my custom subassemblies. I can right click on this palette, choose import subassemblies, choose the source file so I can actually go and navigate to it. Let me just quickly go copy this file path. I can pick that subassembly, click open, make sure the correct palette is chosen, click OK, and that will then import my curb and gutter. Okay, so essentially what's going to happen now, let me just quickly to showcase this, create a quick assembly. All right. So, there we go. Assembly, create assembly. I'm just going to give it any name. The type doesn't really matter in this case. And let's go and add that object to our assembly. There we go. My subassembly is there. I have my concrete width, concrete depth, width 1, width 2, flow line depth. And if I set any of these, let's make this 2 meters, you will see that it now keeps your flow line in the center. It's just that it will not display with the slopes. It has to be controlled by a profile. So that is what's going to affect that depth. Let's change the flow line depth to, okay, so the control won't work in this case, the variable there. So in this case, let's change width 1 to 0.3, and that will adjust the actual width of that object there. Let's change it back to 0.15. So you'll see that you have all of your variables and parameters now written into this. And that is basically it. You can now go ahead and create a corridor from this object. Okay. And that is it for composing a simple subassembly. You will be able to use this video as a guideline to help you in your own creation process. Okay, so we're just going to have a quick few minutes to go over some questions, if there are any. Okay, so there's a question from Yaku now. This is extremely simple. Would you recommend more training, or are there more advanced tools to focus on? So this was just a very basic overview. You can do so much more with this tool. I would recommend, however, maybe talking to me or Salome. We will post our details in one of these chat boxes. You can contact us at any time. We can come and have a chat with you, figure out what exactly you need, and maybe we can customize some sort of training for you, because that is what I definitely would recommend. Okay, so it doesn't seem as though there are any other questions. If you do have any questions after the session, please feel free to email us. We will be happy to answer. I see there is another question. Does this work for tunnels? Short answer, yes, but it does take a lot more parameters and a lot more work going into this. Tunnels are fairly complex objects that do need to be planned out properly, but yes, I'm sure you definitely can. Okay, any last calls on questions there? All right, everyone, so we're going to stop the session here. You can post any additional questions to either me or Salome, and we will be more than happy to answer it. Enjoy the rest of your day, and thank you for watching.